Hello everyone. Today we are going to look at why we are using a bypass diode in solar panels. So last week we have studied the impact of shading on solar panels. So today we are going to understand what is the measure we can do to avoid the shading. That is, we are using a bypass diode to avoid the shading. Let's go into the slides. So before understanding about bypass diode, we have to understand the connections diagram. So here we have solar cells are connected in series. In one solar PV module, we have 36 solar cells connected in series. So this is the fundamental setup of a solar module. Let's say this is 250 watts solar module. We have 36 cells, each has 9 rows, 9 into 4 36, and it's connected in series. Now if we do not have a bypass diode, what will be the problem? So the problem is that if one single cell gets shaded, then the entire module will produce no power, no power output. It means, as we already learned in last video, the current flow is like a water flowing in the pipeline. So if you stop or block the water flow in somewhere in the pipeline, so entire water will be blocked. It's simple that you will not receive any water at the end in the tap. It's the same scenario here. The current has to flow through all the 36 cells. Okay, so now we move on to what is the application of diode in these solar panels. So look at this diagram here. We have a solar cell, and here we have three solar cells, two active solar cell, one inactive solar cell. So inactive solar cells mean that this particular solar cell has a shading problem. Because of shading problem, it become a high resistance. So now the current will start to flow through the diode. So this is the idea. Instead of flowing through the solar cell, it can start flowing through the diode. So this is the idea. This is the application of diode. But we have to connect this diode in a reverse bias. Okay, this is positive, this is negative. Okay, here we have a negative, this is positive, and this is negative, and this is positive. For each cell, we have a positive and negative. Why we have to connect in the reverse bias? Because in the usual healthy condition, the current should not flow through the diodes. So that is the reason we are connecting the reverse bias. It means like we don't want current to flow from here to here. We don't want this to happen because it's a healthy cell. It means like if the cell become unhealthy, then it's become a resistor, high ohms resistance. So in that condition, the current start to flow through the diode. So that's the purpose. Let's move on to the next slide. So look at here, we have we can connect this diode between number of cells. It's depend on the manufacturer's design. Okay, look at here, we have 4 cells and we connect here. We have 4 cells, we connect here. Look at here in this diagram, we can clearly understand that how this connection is working. Okay, so we have the current start flowing from here to here all around this part. This is the understanding. We have a solar panel here, entire panel, and this is your load, and this is, you can understand, like a battery. A solar panel is like a battery, so it's giving a current to the load, usual scenario. Okay, it provides a current to the load. Now what happens, like let's say this and this particular section is shaded. Okay, then what happens in actual scenario, the current will flow from here, it comes, it's use this path from here, it's come here and goes here, and it uses the diode to flow from here, because this is a high resistance, because now because of shading it become high resistance. Okay, so this is completely is out of the game now. So this is go from here and it flow from here and coming back to the load. So basically, what is the understanding here, that the whenever the cells are shaded, a particular section of the cells are shaded, then the diode will be active. Okay, it become a forward bias because the current is coming here, it goes through the diode. And simply you can remember this current going to go through the diode because the diode has less resistance compared to the shaded cells. So this here we are separating some number of cells into section, like 3 section, and we are connecting 3 diodes. You can separate into multiple section and you can have multiple number of diodes. It's up to the designer's perspective. Okay, look at here, we have another example here. This is a shaded area. Because of shaded, this entire area we cannot make use of it. So what is happening, these this current passes through the diode. This current passes through the diode and come here and then flows from here. Actually current passes from here. Okay, so look at this diagram here. This is a good panel. This is a good panel, and here we have a shading problem. This particular area is shaded. Because of shading, the current has to flow through the diode. Look at this connection here. It start here and comes, and the current has to go through this path. Okay, so this is application of the diode. This is a practically, you can see behind the panel there are like a black color box, small boxes there. It's like a junction box, and inside that, if you open there, you can see these diodes. So from today's understanding, what we can do, like next time when there's a problem with a solar panel, in technically solar module, there may be the reason the diodes are faulty. What happens if the diodes are faulty? Because of one small cell getting shaded, the entire panel will not have a, let's say this particular cell, one cell is shaded, the entire panel will not produce any output. So actually these 3 diodes, bypass diodes, are dividing the panel into 3 sections and protecting 2 sections when one section got shading. Okay, so it means like you have a solar panel, that panel divided into 3 sections and connected with the diode, bypass diodes. So what is the function of bypass diode here, means that this bypass diode protect 2 sections from the other one which is shaded. Usually shading happen in one or few cells, so that is a reason we are using the bypass diode. Look at this diagram again, the same diagram explaining the same concept. Here cell 1, 2, 3. If one particular cell shaded, simply the current will pass us through the diode. Okay, because shaded cell always have a very high resistance. So in simple electrical concept, current will always pass us through a low resistance path. Current will always find the low resistance path. So low resistance compared to the shaded cell, the diode has less resistance, so it passes through the diode. Look at here, this is between 2 panels. You can have a bypass diode between 2 panels as well. Sometimes some in a huge installation like 1 megawatt or more than 100 kilowatt installation, we have multiple number of panels. So in that case, maybe the entire panel can get shaded. In that case, you can have a bypass diode to bypass the panel. It's about the design. It's about the idea, how they manufacture, and do you want to install the bypass diode between the solar panels, or if you want to install the bypass diode within the solar module. So usually it's up to the design, how you are designing your system. Usually we have a, nowadays every solar panels will have a usually we have a 3 diodes, the bypass diodes behind the panel. So that's always is there to protect the system. That's all for today. Thank you very much. Please subscribe this channel and to get more videos on this. Thank you.